I'm visiting from Japan, and this is my first time in Dubai. So I'm so excited to speak with you and to have the opportunity to be here. Today, I will be sharing how manufacturing 4.0 is applied to the food and beverage industry, and special focus on case in Japan. Here's a quick look agenda, today's agenda. And first, I'll briefly introduce about our Yokogawa's business and share, after that, I'll present issues, currently issues inside the food factories. And after that, I will explain what manufacturing 4.0 is and share our concept behind it. And I will present a success story from Japan, the Nissin Foods Kansai factories case, and how they approach to their smart factory. So this is our three segments of our business. First, energy and sustainability. This is our main segments, such as oil and gas. And the materials, it's like chemicals or something. And life business, it includes pharmaceuticals and food. And I work in food business, so I belong to this life segment. So this is our concept and our goal. Our concept is so simple, but it's so powerful. Concept is measure, analyze, and integrate. These three elements form the foundation of our strategy. And we realize to BIA through this concept. BIA is a shift in Yokogawa's culture, automation to autonomy. And with this concept, we aim to transform how the food industry operates. Now I would like to talk with my experience about the current food industry's issues. In the food industry, customers' expectations are very high. Even one case of contamination can cause a full product recall, which hurts the business and your which hurts the brand and your business. Customers want both high quality and low price. Even though the ingredient and energy, the cost is keep going up. So we must improve the quality and reduce cost at the same time. Running a business in this environment is very, very, very tough, and I feel the challenge every day. So what are issues inside the factories? This part explains the problems that occur throughout the production process, from receiving materials to shipping the products out. In the food factory, automation is very difficult. That's why human error occurs and misoperation happen. So we can divide these issues for three segments. At first, it's shop floor. Shop floor, as I said, the mistakes and human errors happen. And quality control. We must meet strict standards and enterprise level. Then data and factory systems are often disconnected. So as you can see, there are many issues inside the factory. But I believe these problems can be solved by power of the technology. So I explain how these issues can be solved, the technology. So what is manufacturing 4.0? Manufacturing 4.0 means applying the food industry, industrial 4.0 ideas to manufacturing and production. It uses technologies like AI, IoT, AI, equipment monitoring, cybersecurity, cloud computing, and digital twins. These tools help manufacturing 4.0. Oh, sorry, could you fix it again? And these tools are manufacturing 4.0. And this is our concept, as I said. So our concept is measure, analyze, and integrate. And this concept is also important for manufacturing 4.0. We use IoT to measure inside the factory and analyze equipment status and analyze data with AI and integrate, go beyond the factory and using digital twin, cybersecurity, and cloud computing. To support our concept, there is the ISA 95 model. So ISA 95 model, so the factory systems divide the 4 levels. Level 1, measure. It includes field instruments. And level 2, control systems, like DCS or PLC or something. And level 3, factory systems, like MES or LIMS or something. And level 4, business level, like ERP. And this ISA 95 model is matches for our concept. Level 1, measure. Level 2, analyze. And level 3 and 4, integrate. So this is a before and after digital transformation. And in this time, I want to talk about the detail. If you any interest, please come to our booth after this seminar. Okay, so now let me talk about the real case in Nissin Kansai Food Factory. This is the basic information about Nissin Kansai Factory. This is one of the biggest. This is one of the largest company in Japan, and this factory producing 4 million meals per day. According to my research, Dubai's population is around 4 million. So this factory could serve one of the cup ramen for each Dubai's people. So, and there are degrees of environmental, and they care about the efficient of the energy. And they have a concept of this Nissin Kansai new factory. Their concept is a next generation smart factory. This concept is elements, 3 key elements. First, quality. Second, cost. And third, delivery. This is often called QCD. So their main meaning of concept smart factory, they have to reach a high level of QCD. This is the core idea of their smart factory. And this project was done in 3 phases. Phase 1, the basic concept, is the most important phase. So we took 2 years for this phase. And what the basic concept is including? A basic concept divides 4 steps. First, understand the design for new plant and understand existing plant process. After, clarify existing plant issues, and finally, set basic concept for a new plant. So, and they classify their existing plant issues. There are 75 issues of existing plants. And from these issues, they decided to what systems is implemented, and they decided 5 key systems to implement, and they sort how these systems are connected. This on the right side, there is systems. We implement 5 systems: manufacturing execution system, plant information management system, maintenance management system, production scheduler, and warehouse management system. So, and Nissin factories are conscious of these levels connection. And in this time, I said our concept, measure, analyze, integrate, is very important to connect these levels of the systems. Okay, so how did the factory change after their new factory? So on the right side, there is NASA room. They wanted to call NASA room, so it stands for Nissin Automated Surveillance Administration. They can monitor all of the processes from this NASA room and send commands in real time. And this on the right side, there's AGVs. Like AGVs and other equipment receive these instructions and commands and carry out tasks automatically. Before their digital activity, they struggled with labor shortages, but they overcome the labor shortage issues and their factory visualization and their correct cost control. They can achieve their QCD goals. And not only they achieve QCD goals, as continuous with our Yokogawa will help the go beyond to manufacturing 5.0. Okay, now this is conclusion. Today, I talked about our concept, measure, analyze, integrate. And it's so important for the food factories. And food factory has many issues. And I refer to manufacturing 4.0 and ISA 95. Yeah, and these models is matching for our concept. And I introduce the Nissin success story. And basic concept is so important. And we took 2 years for this phase. And by focusing on data connections, awareness of the analyze, measure, analyze, integrate, and they achieve QCD goals. Okay, so today I'm not here to sell our products. I wanted to share with my experience and how the food Japanese companies will achieve their purpose. So if you have any tips from my stories, I'm so glad. And I hope we will make a better life and to contribute for the sustainability world. Thank you.